सरस्वती देवी को मेरा नमन. Good morning, friends. We are here to have the ISTE approved webinar on deep learning using Python. So for that, who will give us the knowledge about that? That is Mr. Manthan Salanki. Who is that? He is the alumni of our C.K.Pithawalla College of Engineering and Technology. He is a combination of technical and art together. During his college days, he took part in various hackathons as well as other co-curricular activities. Last year, he did his first internship at IIT Mandir on deep learning, and he has been working on the same for more than a year. Apart from that, he is an amazing photographer. He is an amazing videographer too. And he does very good video editing too. So let us learn about deep learning, isn't it? So let us hand over to our Manthan Salanki. Manthan, you can
Yes,
start.
ma'am. So first of all, thank you for the introduction, and I would like to express my thankfulness to a great faculty and your wonderful lessons in class and also your encouragement. So hello everyone and welcome to the today's session on deep learning. First of all, the thank you for taking time out and being here today. So today I'm going to cover some basic parts of deep learning, then the practical session and the Q&A session. So the overview of the basic part will I will cover in the 1 hour and then 30 minutes for practical session and last 20 minutes Q&A session for all of you. So let's start with the theoretical session. The roadmap of today's theoretical session in which I'm going to cover some applications of deep learning, what is deep learning, and then a single neuron and the neural network too. Then some terminologies like the activation function, cost function, then optimizer, gradient descent, and what is learning rate. Then forward and backward propagation. And lastly, parameters and hyperparameters, then types of neural networks and available frameworks. So don't worry about these terms. We will look at this point in depth later in this video. So let's start. And also, those who just joined us, welcome, right? So let's take a look at the glimpse of the variety of tasks which we can do with the help of deep learning. So first of all, the classification problem. Now, what is the classification problems? So the classification involve predicting the which class an item belongs to. So here there are some labels. So which can also we can say that the class, let's say the aeroplane, the automobile, the birds, cats, there, etc. So these are the individual classes. And if we have a set of images mixed together, so the our model can predict that okay, this image is from this class. If the image is the plane, image contain the plane, then our model can predict that okay, this image is of the aeroplane. So this way, the classification problem can be deal can be very easily implemented with the help of deep learning. So there are so many kind of classifications are there. Some are the binary classification, means the resulting in the yes or no, whether it is the cat or not, whether it is the human or not. So these are simply giving the yes or no answer. And then other type of classification problems are there. The multi-class classification. This is the image in this slide is the example of multi-level classification, because we have more than two classes. So this is called the multi-level classification problem. And then we will look at some other classification like the multi-class classification, which is like the image contains more than one class. Okay, so image contain the birds and human, birds and animals, and also, so the model can have to predict both of them from the same image. So this is called the multi-class classification problem. So the classification task can be done easily using deep learning. Second, the annotation problem. Now, what is the data annotation? So the data annotation is the process of adding metadata to our data set. Now, what are the metadata over here? So metadata are like, okay, so let's look at the first picture here. So here we can say that this image contains the sky, jets, planes, smokes, and formations. So the human annotations are the simple, like skies, jet, planes, and smoke. But our model predicted that, okay, so these are the metadata for this particular image. For that, the second one is also looks like the same, like the grass, sands, valley, crayons. This is the human annotated label. So why we required annotated data? So we all know that the adding the comprehensive and the consistent text is the key part of the deep learning. So these metadata are useful during the training task, right? So I'm telling my model that, okay, this image contains this kind of data, so you have to remember this particular patterns. So later, if I will import any image, so if it found the similar pattern, so it will trigger that particular metadata. So this is the labels available in my particular image. So this is the annotation problem, right? Now third one is the detection problem. Now detection problem, we all know that the detection problem is look very feel good for us, like, okay, that some autonomous driving car uses this like deep learning. They all we heard the news about that the SpaceX use deep learning for their own autonomous cars. So what they actually using? They actually using deep learning behind the scene. How? So they have the cameras in front of their car. So it's constantly capturing images and they are processing in real time. So detection problem is the combination of the object classification and the object localization. Now what's the object classification? Object classification, we just say in the last two slides that the identifying the image, like what is the label I have to give for that particular image. And what is the object localization? Object localization involving the drawing bounding box around one or more object in an image. So what is bounding box? Let's take a look at this particular image. So here the image contains the two-man cycle and the streets. So the bounding box around the person one and person two. And the object classification means providing label to that particular object, means the person, this is the person, this is the street light, this is the tree. So this is known as the classification. And the bounding box means the object localization, and both of them combined together gives the object detection. So if I can provide some condition like that, okay, if the man in front of car, I should stop my car. Okay, so this kind of condition I can give to my model. So it is useful during the autonomous driving and later it will learn in that particular way, right? So after that, the fourth application of deep learning is the GANs. So what are these GANs actually? So first of all, let's look at these two pictures. This person does not exist on this planet. This is reality. These faces are generated with the use of GAN. GAN means the Generative Adversarial Network. Now, GANs are the generative modeling. So they involve in input data and they generate output data in such a way that it not coming it's not based on the input data, it's like just a creation of something new. So these images are generated from the noise and we have the input data of so many faces. So it is the combination of noise and the features of our face. So this is a very cool website, everyone should visit it once. So like every time if you open this website, this image is generated, and some side notes are over there, like this image is generated by the style GAN. So there are various kind of GANs, and it is backed by the NVIDIA. So every time you refresh the website, there are peoples and the faces. These are does not exist on this planet. Look at the details of this face. It's take a lot much computations. So that's why these GANs are a very great generative model examples, right? So let me just refresh my frame. Okay, right. And the next application is the neural style transfer. So neural style transfer is an optimization technique used to take two images. First is my content image, second one is my style image, and blending them together in such a way that it's the look like my content image but painted with the help of my style image. So here the famous painting, the Starry Night. If I want the same exact image, same exact design on my own image, so I can use deep learning, and I can extract the features from the first image, it is my content image, and I can extract the style image, style from the second image, and I will blend them together in such a way that I can get this kind of beautiful image. So this is a very great example of the filters. Like we know that there are so many applications available in the market, they use this kind of filters, and they also add in their advertise that we use the deep learning. So this is the deep learning, this is how they are using. So the famous example, we all know that the Snapchat has a very great filters, right? Now what Snapchat are doing, first of all they identify, they localize our frame, they localize the point, like this is eye, this is ear, this is lips. So after that they are applying that filter on our face. So this is how we can use new deep learning to get some artistic new images like that. So these are some application of the deep learning. Now, what is deep learning actually? We all know that this term is very famous and it is taking off great from last decades. So I just want to give you a brief idea, like how this actually happening over from last 10 years. So let me just give you a brief idea about the performance versus input data graph. Now what is that? So this is my input data, right? And what actually happening? So first of all, let's take an example of a traditional machine learning algorithm. So traditional machine learning algorithms have the performance like this. So after a couple of uh, input data set, the performance we cannot get much more performance from the traditional machine learning algorithm. But if we use deep learning instead of this traditional machine learning algorithm, so let's take a small neural network. So it will give us a little bit more performance than the machine learning algorithm. This is the small neural network, right? And then if we take some larger medium sized neural network, so medium sized neural network give slightly more better performance compared to the small neural network. And then lastly, if we use the larger neural network, so it will provide us the better performance on our input data. So this is why we are using deep learning. But look at this point. We require high performance and input data. So that's why deep learning is so popular from last a decade, because the computational power, we have enough technologies, we improving daily. So the daily basis technologies For now, let's take a look at the scenario of before 10 or 15 years. So that time we don't have GPUs, TPUs like the tensor processing unit and all. But now we have TPU, GPUs, and we have the enough processing power. And thanks to the all cameras and technologies in that we have the improved sensor, and we use 3 and 4 cameras on our mobile. So input data are also very huge. So the input data and the high performance give us the better power to use these technologies. So deep learning is that's why popular during these days. Now I am giving you the brief idea about the artificial intelligence. So we all know that the artificial intelligence is the any techniques which enables computer to mimic the human behavior. So let's take a look at the example of any robot. So what are the machine learning tasks? The machine learning task is the computer's tech ability to learn without being explicitly programmed to do so. So once we code something, and then our computer learn by trial and error method, and it is doing the same task repeat and the iteration, and then it learns the task. And machine learning is the subset of deep learning, and the deep learning is the subset of machine learning and concerned with the algorithm inspired by the structure of our brain. So why deep learning? Deep means there are a deep neural network. There are lots and lots of neurons available there, and it is the combination of more complex computations. Okay, so computes that solve more complex problems, and this is the example. So this is a great example to understand the deep learning. Why? So the Vyomitra, who is Vyomitra? Vyomitra is developed by our space organization ISRO. So they use Vyomitra for our first humanoid flight, Gaganyaan. So before they send our astronaut to the space, they first send Vyomitra, and it will helpful to get to understand about the crew modules and check what are the status of our flights and what are the changes we need to take. So this is the idea and the example of AI. Then the task which can be done through the Vyomitra. So the tasks are the operating switches, monitoring crew modules, receiving voice commands, responding via species, and obeying commands. So these tasks require deep learning. How? So the computer vision, like they have fitted camera. So the camera can capturing the image, like this is the switch, this is the crew module. I have to look at this module and press this switch. So the computer vision task, face detection, and then understanding the languages and speech generation. These are the tasks done using deep learning. So it can be helpful to our robot. So this is how the narrow down, if you narrow down the field of AI, this is how the deep learning can be helpful to a very large extent. So let's take a look at the machine learning techniques. We all know that there are two main different type of machine learning techniques, are the supervised learning and unsupervised learning. So first of all, what is unsupervised learning? So unsupervised learning is the approach to a problem with a little or no idea about the output of our model. So what is the unsupervised learning? We have a mixed set of input data, and we are getting structuring those data. Okay, so same kind of pattern we are putting into the same cluster. Cluster means the grouping data. So after that, we can provide the label to that particular cluster, right? So we don't have any predefined label. We have just data, and we are learning. We are getting some common functionalities. We are getting some common patterns, and then we are classifying those data. We are grouping them to data. So this is the unsupervised learning. Then we have supervised learning. Supervised learning means we have a data set, and we already knows the correct output. Like we have the data set of digits, okay, an and image, and we have the labels. Like this is the image of 0 and the label is 0. So this is the data set we when we have the data and available true labels. So after that we are using this data and classify and predict the future data based on this available data is known as the supervised. So again, classification is the classified data based on the classes available, and regression means the predicting data and putting all input data in the continuous manner and then predicting from that. So this is how the classification, regression, and clustering are done with this help of. So are these techniques? Okay. So now, what is neural network? So neural network is one of the several machine learning algorithms. As I tell you before, that we have other machine learning algorithms, but these use the anatomy of our brain, how our brain works, how our brain sees any particular image, if and what are the process happening in our brain. So it is a collection of the nodes called artificial neurons, and which usually model the neuron in the biological brain. So this is known as a neural network. So neural network contains so many individual neurons. Now what is the individual neurons? So individual neuron is the combination of a linear unit and activation function. Now this is the linear unit, and activation function, I will cover this activation function later in upcoming slides, but first let's look at this linear unit. So linear unit have a simple function, y is equal to wx plus b. It's more like y is equal to mx plus c. Just remember the class 10th class when we have the equation of line, right? M was the slope and c was the constant. So it's just as the same, that wx plus b, where w is the weight and b is the bias factor. Bias is also a one kind of weight. Okay, so here are the example. If I want to calculate the calories from the sugars, so I will enter my input x as 5. Here I have the weights w is equal to 2.5 and bias factor is 90. So after multiplying and adding bias factor, so I will get the calories of 1 not 2.5. So this way the linear unit calculates for individual inputs. We can have more than one inputs too. Like this is where we have the input features x0, x1, and x2. And according that we have the weights w0, w1, and w2. For each and every neuron, we have a common bias factor. So the calculation over here is y is equal to w naught x naught plus w1 x1 plus w2 x2 and b. This way we will calculate the linear unit, right? So let's I just want to give you an example. If I want to calculate calories based on the sugar, carbohydrate, and etc. So sugar will multiply with some with its own weight, carbohydrate will multiply with its own weights, and I will add another factor. So this way I will calculate the linear unit, right? Now let's look at the activation function. What is the activation function? Activation function are mathematical equation that determines the output of neural network, right? So what is the our defined what is the meaning of determining the output of neural network? So I just want to give you a brief idea. Like I have one particular neuron, and the output is this simple linear unit. Now the output is very big, like 1 or 2.5, but I just want to put it on a common scale. Okay, so this where we can use the activation function. So they define the output of a neural network based on our available input. So it is helpful to fire whether this neuron will be active or not, whether it will send the particular signal to the next neuron or not. This is the decisions are take from the activation function. So there are commonly three types of activation functions, and the linear activation functions, heaviside activation functions, and the sigmoid. But what are the sigmoid? So these look at these first sigmoid activation functions. So it the formula is the sigma of x is equal to 1 by 1 plus e raised to minus x. What this sigmoid activation function do? The whatever the input coming for this activation, it just simply give the output from 0 to 1. Okay, so where this sigmoid activation function will helpful to us, like if I want to classify any input data based on binary classification, like whether this is cat or not, whether this is human or not. So what I will do, I will simply assign label to the image of a cat is 1, and the rest of the image I will assign the label 0. So what will happen, my model will find that okay, if I will get the image of cat have some similar features, I will fire 1, and if I have not the kind of the same image, so I will fire 0, and then I will tell the 0 means not cat and 1 means cat. So this way sigmoid activation function will helpful to classify input data set. Same as we have the 10H activation function, but the 10H activation function gives the output in range of -1 to 1. ReLU means the rectified linear unit. So it is very common and most useful nowadays because it is a combination of, this is called the linear activation function because here we have the 0 for all negative values, and x means the same value we are passing to the next neuron because we are not calculating anything. So okay, so this is the rectified linear unit. Then we have a leaky ReLU, the slightly better version of the ReLU, means we are calculating 0.1 into x and x. So rather than putting 0 for our negative values, we are getting slightly better negative values. Okay, and then the max out, the maximum value from any features, and LU. LU is also same as the leaky ReLU, but in conditions. Okay, so this is the example of sigmoid activation function. Like this is the graph, and what happening, I am passing my linear unit to my sigmoid activation function. So linear unit was wx plus p. Okay, so if I send the threshold for 1, like if I am getting the activation value greater than 0.5, then it is cat, or if I get the values less than 0.5, then it is dog. Okay, so this kind of classification is done using sigmoid activation function. Then we have the dense neural network. Now, if I combine individual neurons, then we have this dense neural network where we have the input layers. These are the input features like sugars, carbohydrates, and all. And then we have the combination of layers, and each layer contains any number of neurons. So in this first hidden layer, we have 128 neurons. In second hidden layer, we have 64 neurons, and later this is the output layer. So why we have the 10 output layer? Because this is the dense neural network which can be helpful to classify whether this number which is what, like okay, this is 0, this is 1, this is 2. So for the end layer we have the 10 neurons. So individual neuron is for individual number. And now this is what, loss layer. Okay, so I will cover this loss layer in the next slide, but before that I am going to tell you that each and every neuron is connected with all previous neuron. Look at this neuron. It is connected with all previous neuron. This it getting input from all neurons, and it's sending output to all neuron in the next. That's why this connection is called dense neural network. right? So let's coming to the point of this loss layer. Now, what is this loss layer do? What does this loss layer do? The loss layer is the measure the disparity between the target value and the value the model predicts. How? So let's look at this example. Suppose I have an image of 20 by 20, 28 into 28 dimension. Let's say this is the image of 0. Okay. So I am just giving input to my neural network, and my neural network predicts the label 1. Okay. Like this is not trained yet. So it predicts the wrong label. So what happens actually, that the difference between our predicted value and the true value, because we are talking about the supervised value where we have the true labels in our data set. So this difference between predicted and true value is called the loss function. The loss function will give us, loss function will tell us how our model do well on our image. Now, if I have a 10 image in my data set, so I will pass one by one every image in my data, and I will calculate loss for each and every image. And after that, I will average those loss and get the one particular number that called the cost function. That is my cost value for input data. So the cost function will tell us how our model do well on our parameters like W and B. These are the parameters, how our parameters do well on our input data set. So here is the graph of one regression problem. So where we have this true line, that this is the our actual line, and based on the input I am predicting the values. Red dots are my predicted value. Okay. And the actual values is this line. So the difference between this all actual value and predicted value is my loss, and I will average this loss and I will get the simple number is my lost value. Sometimes it's called error too. So there are three terms: loss, cost, and error. Both or three of them used simultaneously individually for them, but the common practice is for individual loss we have the loss function, for average we have the cost function, and the average value it's called the error. So here this is the graph of mean absolute error. So like the activation function, we have the several loss and cost function available for different purpose. So for some problems, we the other activation functions and loss function works well. So these are the training steps. What actually doing during the training step, like we have some input data set. Okay. Now we will feed this data set to our neural network. Then we will measure the loss between predicted and the true value. And lastly, we will adjust the weights in a direction that makes our loss smaller. Third step is very important, because if we have images and model but we don't learn, we have to tell our model that you need to train. So that's why we have to adjust weights, because we have input data set is fixed. The only variable we have is our parameters between these all neurons and bias term. So we have to tune our parameters and bias term in such a way that we can minimize the loss function. So why we want to minimize the loss function? If the distance between this predicted value and true value is minimum, then we can say that for the future values, our model will give the best accuracy, right? So that's why we want to minimize our loss functions. So how we will minimize our loss functions? So that's the optimizer came into the picture. So the optimizer, what is optimizer? Optimizer explaining of coming back and from the top of the mountain. Now what is that? This is the three-dimensional example of the non-convex function. Now what is non-convex function? So they have the local minima and global minima. but the convex function is have the every convex function have the one global minimum. So just assume that you are on the top of the mountain and you just want to go downside. So what are the things you have to do? You have to take steps in the direction where you will go downward. So this is how we are doing and updating our parameter in order to minimize our loss function. So the optimizer is an algorithm that adjusts the weights to the minimize our loss function. Now there are several optimization algorithms available, but one of the basic algorithm is gradient descent. Now this is a very most basic algorithm used for every techniques, and it is heavily used in linear regression and all classification problems. Now what is the gradient descent? So here I write one thing. The idea is that being able to compute the derivation and the slope of function, we can find the minima of the function. Okay. So what actually we are doing, gradient descent is the first order optimization algorithm, which is dependent on the first order derivation of the loss function. Now let's just look at what actually happening in this graph. I have one more explanation for you guys. So this is one graph of our loss function. Now this is the convex function because we have only one global minima, right? And let's suppose I am starting with the loss value over here. Okay, so in starting, my loss value is very high. My model is not know what is right and what is wrong. So it is predicting a wrong level. Okay, so what I will do, I will plot my loss value and I will get the derivation for particular value. So what is the derivation? The derivation in mathematics, the derivation means that first order derivation is the slope of that particular point. So this is the height I will measure and I will measure the width. And for that I will get the derivation of dj. Okay, so what I will do, I will update this parameter for every iteration, and then I will get over some less loss compared to the previous, and after 3 or more iteration I will get the global minimum value. So this is my conversion point where we have the minimum value for this particular loss function. After that we will not get any minimum value compared to this one. So this is how gradient descent works. We are calculating the first order derivation and then updating each and every parameter, and again we are predicting label, again we are calculating derivation, updating parameter. So this way every time I will go after 5 or 6 iteration, and then I will go here in this global minimum. So this is what we want. So if my models have a less loss function, minimum loss function, then I can say that our parameter is well learned on the input data set. So this is what this graph means. So how we can update this parameter? Okay, so this is the derivations. Here you have to just look at some mathematics, but okay, here we need to we required some calculation derivation. What is partial derivation? So just forget about that. Here is the first step. This is our cost function. Okay, sorry, this is our cost function, right? And h of theta is my loss function. Okay, what is loss? Loss for individual images, individual data, and the average is my cost function. We want to minimize this cost function. This is our objective. Now what is the update rule? Update rule means we have a w and b, which are the variables, and we just need to update using this formula. W colon equals, in colon equals means we are updating this parameter w minus alpha. and the partial derivative terms. So what is that? They, we have to we need the first order derivation with respect to this both w and b. So just for I made some mistake over here. This is not theta 0 and theta 1. This should be w and b. Okay. So update rule is this. I have to subtract something from our recent from our available variables. Okay, so this is the derivation term. Like, okay, we know that what is the derivation of the power. The power will be come to the multiplication and power minus 1. So 2 will be removed. So this is our derivation term, and this derivation term will multiply with the alpha. What is alpha? Alpha is the learning rate. I will explain what is learning rate in the next slide. And this combination of multiplication, I will subtract it with our parameter. So after one iteration, I updating my parameter. That's why after the updating parameter, if I am calculating again the loss, I am getting the second point. Now again I am calculating the derivation, again I am multiplying with learning rate and subtracting, then I will get this third. And this way we will go to the final value where our graph will give the convergent value. Okay, so this is the derivation. Now what is the partial derivation happening in this our hidden layer? So this is the partial derivation. How we can do the derivation dj with respect to dA, because we need derivation with respect to our input variable, our input parameters. Okay, so there are some parameters, and this is the calculation. We want dj with respect to dA, so we will not get the direct derivation. So first we will get the derivation with respect to dv. So this is the simple one variable derivation. So this is like example, what is the function if we want the dfa with respect to dA, and the function is 3a. So we will get 3 because v is variable, so it will be the 1 after the first order derivation. So we will get the dj with respect to dv will be value will be 3. And now I will calculate dv with respect to dA. Okay, so dv with respect to dA, here the partial derivation will be used because we have two variables, and we are getting the derivation with respect to any one variable. So as per the partial derivation rule, so the rest of the variable act as a constant, right? So what will get the output of this first order derivation is 1 plus 0. So this will be 1. Now what is the final value? Right, this is the d with respect to dA, this is 1. And the final value dj with respect to dA is equal to the chain rule. Just remember the chain rule, dj with respect to dv multiplication dv with respect to dA. So 3 into 1. So the derivation of dj with respect to dA will be 3. Now as per the rule, I just calculated the derivation of dj with respect to dw is 3. Now I have the learning rate like 0.001. So what is my updated parameter is equal to w minus 3 a multiplication with 0.001. So every time I'm subtracting this value from my variables. Okay, so this is how we are updating our parameters. But here the most important term is learning rate, because with whom we are multiplying is very important. Why we need to update and why we need to choose the right parameter, right learning rate, because here there are the three scenarios. First one is, if I will choose the learning rate is too low, means I will select the learning rate is 0.00001. So whatever derivation will multiply, it will give the minimum value, and it will subtract the minimum value from our variable. So I will get slightly less value from the previous one, slightly less, but it takes more time to conversion, and it will take more computational power. So we do should not choose a too small learning rate. Similar, if we choose too high learning rate, then it will take a big step. It will subtracting a big value. But if it will take a big step, then if I have the initial cost for value is this, I will come to this, I will come to, but I will never come to the conversion point. Okay, so it act as a divergent behavior. But the right parameter for learning rate is, the right value for learning rate is, I need more bigger values, but if I am getting to the conversion point, I have a less value. So this is how the learning rate should be choose before training the model. Okay, so this is why learning rate is very important for our model. So let's put this all together in this forward and backward propagation. What actually happens? So this is the linear unit. First of all, this is our input. We have two hidden layer, and the third hidden layer is our output. So first of all, what we did the individual neuron. We have the individual neurons. So we calculate what happens in individual neuron, the linear unit and activation. So we are calculating these two steps, linear unit and activation, for all hidden layers, and coming to this point. Now we are calculating the loss function. Okay, what is the loss function? We are predicting, and we are getting the value from this predicted and the true value. Now we have the loss value. Now we have to update this loss value in order to get the minimum. Sorry, we have to update our parameter. Okay, in order to get the minimum loss function value. So how we can update our parameters? First of all, we need the derivation, and we are subtracting again, derivation, subtracting again, derivation, subtracting. So this is the chain rule, and we are getting the derivation with respect to our input parameters. So this step is known as backward propagation. Whatever the calculation we are doing up to the loss function, this is known as forward propagation. So after the one loop, we are again calculating value, again updating the parameter, and getting the less value for our loss function. So this is how the training happening in our neural network. So this is one brief idea what happening during the training steps. Okay, so look at this first graph. We have this particular line, so we started with any random number of weight and bias. That time the training loss was very high, because we don't have we don't learn, our model didn't learn the parameter very well, and that time our weights are look like this. After the second iteration, it was slightly changed, our loss is slightly down, and then our parameter is updated. And after the couple of iteration, we get the possible better value of W and B for this input data set, and we have this minimum loss function, loss value, and we are getting the weight and bias after the training set. So what is the batches over here? Now batches are what we are processing data in a particular batch. If look at the scenario, if we have a tons of data which we cannot fit once at a time, so what will happen if, let's suppose, we have the 100 images. So I will feed my neural network with every time the 10 images. So what will happen? 10 images came. After that, the loss value is calculated, backward propagation happening, and update parameters. After that, again 10 images come, and then I am calculating the loss value, getting average, and doing backward propagation and updating the parameter. So this way we can calculate the more data set on the less memory, because once at a time all data cannot fit into the our computational memory. Okay, that's why we use the batch here. It's the batch of 6432 as per our computer can process. So this way the training happens. Now what are the parameters and hyperparameters? Now the parameters are that which are variables we can change during the training task. Now, what is the parameters we can change? We are updating the W and B each and every time. So this is known as the parameters. And what are the hyperparameters that we cannot change during the training task? It's like the number of iterations. Like I have to define before training that I want 10 iterations for this model. What is the test size? What is the length of training set? And what are the hidden layers? And how many numbers of neuron each layer? So these are called the hyperparameters. So learning rate is one of the hyperparameters because we have to define it before training set. And there are some algorithms, optimization algorithms available which set the learning rate automatically, but learning rate is a very important hyperparameter that we have to take care of during our training task. Okay, so this is the parameters and hyperparameters. Now analogy with the human brain. So what is the neuron concept came from? So we have these kind of neuron in our brain. So there are dendrites, nucleus, cell body. So it's connected, dendrites connected with the other neurons. Okay. So let's take a example. If I am watching phone, so the image of phone captured by my eye, the input signals came to the going to my visual cord, and then the neuron fire and send output to these neurons, next neuron. So if this nucleus get enough electric current, electric signal, then and only then it will fire and send signal to the next neuron. So the same concept used in our neuron, like we have the input, we are calculating the linear unit. Now what is the decision making step is activation function. If I will get enough input, then and only then I will share to the next. So here activation function send 0 or either 1 in case of sigma activation function. So this is how the neuron is deal same as working same as our human brain. Okay, so this is the great example how the neuroscientists and computer scientists use this concept to calculate these kind of neurons and merge them together and calculate the neural network, make the artificial neural network. So the more intuitions about the deep representation. So what happening inside the hidden layer? So first of all, I have the image of 9. So this is the 28 into 28 dimension image. I am flattening out this image. So I have this input data set is 28 into 28 is 784. This is my input. In the next layer, I have some other numbers of neurons like 256. So each and every neuron has the input, and they learn the different pattern because they all have different weights and bias. Okay, so these neuron, it's like okay, the dot, this neuron predicting value like the common vertical line, then other will the horizontal line, other will some inclined line. Now these all values merging them together, it's are the input value for the next layer. So in here, these neuron like identifying the common features like the circle, these identifying the features like the horizontal vertical line, other the more inclined line. Now 9 is the combination of circle and line. So these two neuron fired, and this combination of a circle and line give us the value 9. So the output will generate in this way. So this is how and what's happening during our hidden link. But just don't forget about the mathematics behind this, because we all know that individual neurons are the combination of linear unit and the activation function. So these activation function activate and send value to the next. This during this input, this function is not activated. It will send you the value 0. So the combination of 10100 will activate the value for this particular neuron, and these two neuron activate and then send the value of 9. This is how the neural network have the visual representation during the hidden layer. So one more example of the fish. So in first hidden layer, it learns a very low level input features like the dots, like some lines. In the second hidden layer, it will learn some more abstract features like the combination of zits, dot and some lines creates eye, nose, lips and all ears, and the combination of different eyes, nose, lips creates more high level features like the face, forehead, the face of man, woman, like the fish have made is the small mustache over there. So this is the how the different high level features learn in this final final layer of neural network. And according to based on this final layer, this input have like the similar features like this particular neuron, so it will activate this particular neuron and we are getting the high value. This way we are getting the final output. So after this, we have the various type of neural networks. So there are mainly three type of neural networks available here. First of all, the artificial neural network. We just saw this artificial neural network, which is connected tensely. And second is the convolutional neural network. So rather than applying images directly to the dense neural network, first we are passing those images from the convolutional neural networks where we have the kernels, filters and learns different features from the images like the hard edges, soft edges. So this is learned using this convolutional layer and then we are passing these features to our densely connected neural networks. And this is widely used for image classification recognition purpose. And the third one is recurrent neural network. Recurrent neural network is widely used for generating the time series data. Like okay, we if we want to generate some temporal data, which means it is based on the previous data. Now what time is it? This follows some specific structure. So what actually happens, the first what is predicted, based on that the second neural is predict the value like keyword time, based on what and time will be the input of my third neuron, and this way it is generated the is, and these three will be input for my fourth neuron it is, and then I will generating structuring my sentence. So this is how recurrent neural network. And the other version of recurrent neural network like the long short-term units like LSTMs and other hybrid units are used to generate and useful for different tasks. So these are the deep learning frameworks available for us because these are very important. We cannot program each and everything in depth because every time if we are just taking care of forward and backward propagation, then it will going to be the much lengthier for us to code. So TensorFlow, Keras, MXNet, PyTorch, these are some common and famous deep learning frameworks which already provides some functions. Like if we want to use ReLU, then if we want to use sigmoid, then every time we don't need to write the formula of sigmoid activation functions like 1 by 1 plus e raised to minus x. We just type the sigmoid activations and it will take care of all mathematics behind the scene. So the common popular framework is TensorFlow and the PyTorch. So if you want to use TensorFlow, then it is good for development of the model production. It has a very great community. Then it has very comprehensive documentations too. Then so widely used for the mobile platforms too. And other it is PyTorch. So PyTorch is more like Python. We have to code like a Python. So if you want to, it provides a more customization option. So it is widely used for research purpose, or if you want to just require some better debugging experience because you have to create your own functions. No doubt they have also available the other libraries also, but it is more Pythonic. So if you like to just work on these research purpose, you can definitely go for the PyTorch. But my advice should be like that, just go for both and then decide which one works better for you. So these are the famous pre-planning frameworks are there. And now I'm going to look at I'm going to take one practical session for the image classification. So I am created one Kaggle notebook for you. So it will be helpful to understand the classification tabs in more depth. So no worries, I will share this link later, and just go through this notebook and you will get the better idea and intuitions about each and every steps. So let's just code this particular problem. So I have created this notebook. So let's start with this session. Okay, so why keras? First of all, I am going with the keras here because keras is a very great library for any beginners. It they provide the all functions layers, and you have to write more abstractly during your code. So TensorFlow and keras is widely used for the classification, and if you just want to start with deep learning, then I am suggesting that you can go for the keras. So here the title is the image classification with MNIST dataset. So what is classification? Now the classification is the process of predicting the class of the given points. Okay, as we seen above in the presentation deck. So this is the binary classification, multi-class class classification, and multi-level. So binary means the 0 or 1. In multi-class we have some labels and classes, and multi-level we have to identifying more than one classes in this single image. So this digit MNIST dataset is the multi-class classification problem. Okay. Now the five deep machine learning tasks steps. So first of all, we need to get data. So we need to get data from any of the sources. Then we have to prepare our data. Means that we have to first clean, removing null entities, filling the entities, and other columns are there. So this is the cleaning our data and preparing for our model. That means in which way I will feed this data into our model. Okay, so this is called the preparation step. Then the training step. What is the training step? As we seen and as we saw in this presentation deck, like we have to move to the over and over iterations and reducing the loss. This is called training. Then we are test our model on our test data, and then we can change our parameters, hyperparameters, in order to improve our model. So first of all, I will import some packages. Some important packages are the TensorFlow, Keras, NumPy is a scientific computing library for Python, Matplotlib is used for the graphs, and OpenCV is computer vision library. So I imported this, I already write this library over here. I'm just simply running this command, this particular code shell. It is processing right now. Okay, and then I am simply run this second step. So what is that? Import TensorFlow SDF. We know that the Python have a very Python is a language. It's just you can write like an any English, and in this way, import TensorFlow SDF. So we are creating alias for this library. So whenever I need to write use this library, I will simply use the tf dot kind of something statement. Then I am importing from TensorFlow import keras, and then import numpy as np again same, and import matplotlib.py or pyplot.plt, and import save. Now this is very important. What is that? So I am importing the load image and image to array. So this we will use later in this notebook. And I am importing the model. So model is sequential because this is the sequential model. Why? Because we have one stack of neurons in one layer, then we are adding the second layer, then we have the final layer. So this is the stack of layers. So this is the sequential layer, and then we need layers like dense means the fully connected, and activation which contain all activation functions. Then optimizer, as we say, gradient descent, but here we have the Adam, and SGD means stochastic gradient descent. We will look at this later in this notebook. And this is the utils.np.utils. It is also help us to transform our data later. So the first step is to the load our data set. Now how our data set is look like. So we have the number of handwritten digit data set of the size 28 into 28 dimension. We have 60,000 images for training data and 10,000 images for test data. Okay, so this is how our data look like. So whenever if you don't know, just go to the documentation site, so you will get better idea about what this data set wants to tell you. So luckily we have already this data set available in the keras. So it contains only one functions like load data set, and argument is the path, and what it returns the simply tuples of xtrain, ytrain, and xtest, ytest. So what am I doing? I am just copying this output, and I'm just write down or paste over here, and also just you just see that how we can use this load data function. So just simply copy this tf.keras.dataset.mnist.load data and just paste over here. We don't need to give any path over there, and then some simply run this, so it will load data for us. Okay, now our data is loaded in this form. We don't know that what is this, so just simply apply this help type function, like what kind of object is this. If you don't know, sorry, type of x string. So it will give us that, sorry, okay, so I have the small x. So it is the numpy.nd array. Okay, if we want the more information about that, then simply write function help. So it will give us the more documentation about this function, like what type of method we can apply on this particular nd arrays and all. So this is the this is how we can look at our data. Okay, so let's check out the input dataset, like what we have in our dataset. So simply xstring.shape, it will give the dimension of our input data. So dimension is the 60,000 28 28, means that the 60,000 images are there, in which we have the 28 height and 28 width of data is available to us. And the same way, if we just want to show about wide range, so it is like 60,000. That means a single array of 60,000 in which we have a labels. So just simply saw any particular data. So how we can see the image with the help of PLT, pyplot library. So the PLT dot I am show xtrain of 0. That means the first image. Okay. And the second I am passing the parameter cmap is equal to plt dot get cmap. What I just want the gray images. Okay, and I just want the label of this particular first image. So y train of 0, this will give us the label 5, and image is look like this, the 5. So don't hesitate to change any images, like I just want to see the 5 fifth number of images, and what is the label of the fifth images. So this is 2, it just look like this. If I just want to see the 5,000 and 5,003, so this is what our data looks like. So this is the our input data. Now we have to prepare our data. Now what is the preparation of data? So first of all, in this case we have the 28 into 28 size images. So in in these images we have to input in this array of in the single array. Why? Because it is look we have the first input layer is the dense layer, so we have to flatten this layer, we have to reshape this size. Okay, so what we will do, we will simply change the shape of our data is equal to x string dot. Let's just first look at the size of our data. Dimension is this. Okay, 60,028 into 20. What we want, 60,000 into the multiplication of 28 into 28 is equal to 784, because we need to give one single array to the neural network. Okay, so how we can change the dimension is equal to xtrain dot reshape function. So reshape requires the tuple, and the input shape for first we just need 60,000. So xtrain dot 0, that means 60,000, and minus 1 means the whatever the dimension, it is simply multiply it. Same for test, x test dot shape x test of 0, because here we have 10,000, right, and minus 1. So after applying this whatever only integer scalar array can convert it into. Okay, so what is happening over here? Reshape xtrain and okay. Hmm, I should just again run this set xtrain dot reshape. Xtrain dot okay. So I just wrong over here. I want a shape dot so I have to write shape of 0, because this is our first image. Sorry, it is my mistake. This is the shape of 0, that means 60,000. X train of 0 means the first image. Okay, so x train dot shape is my 60,000 and test dot shape is 10,000. So now this is right. Let's look at the shape again. Dot shape. So okay, so here we have the updated shape is equal to 60,000 into 784, and just look at the test is 10,000 into 784, right? So the next step is the normalized input data. So we know that the image contains image is a form of matrix, right? So each matrix have the data from 0 to 255. Every channel has a value of 0 to 255, but we need to normalize this data in a common form. So in this example, we will divide our data by 255. So we will get the value from 0 to 1. So where this normalization is mostly useful. So if we have the data in the different unit or different scale, like input data of the length is like the centimeter and meters too. So we need to apply this data in model on common scale. So we will normalize data first before applying to our model. So in this case, we will simply divide our data by 255, and x test is equal to x test by 255. So this is the normalization step. Now the labels for one hot encoding. So just simply look at the binary classification criteria. So if we have the binary classification, so we, as I told you above, that if we have the binary classification, I am giving the value 1 or 0. These are the two individual values. But here we have the combination of 0 to 9 labels. So for each and every value, I have to give them a particular numerical set of data. So categorical data then converted to the numerical data, because we need a common, we need a unique name for each and every classes. Computer does not understand 0, 1, 2, 3. It understands the binary code. So we need to make a matrix of 0 to 10. Okay. So what is one hot encoding? Suppose we have the color class, and in color class we have the three colors. So we cannot say that okay, this is red, green, blue in output. Computer need understand in the binary form. So I will simply make a matrix of 3 by 3, and for red the 100, green for 010, and for blue it is the 001. So this is how one hot encoding is looks like. Okay, but before that I just have to check this prepared data. Okay, so here we also have to convert into the float 32, because every calculation we need the float value. So it is automatically converted to the float later, but before converting to float it is very helpful, and it is a very good habit. So here I am converting my every input data, sorry, input data to the float. So as type of float 32, and the same for test data. So the calculations of the forward and backward propagations and the gradient descent will be done very well. So this is how these input data it's look like, is normalization, and then using one hot encoding. So with the use of one hot encoding we are simply converted our categorical data to our numerical data. So numerical data is like this. So how we can convert the categorical data into numerical data? So we just first of all let's see the shape of our white ray is the 60,000. Now we need to change, and we have to assign a matrix for 10, because we have the 10 classes for each and every classes. So we use np utils dot simple function to categorical pass the white ray. Okay, and this same for the test. So once we apply this, now check the shape of white ray. So this is 10,000, 10, 60,000 into 10. So for each image, we have array of 10, which is the combination of these number. Suppose for 0, we have the array of 10 value, 1 following to the 0. For 1, we have the array 0, 1 following 0, 0 are there. And then this way we have converted to the categorical data into the numerical data. We assign single binary value for each classes. Okay, and then I am simply making the number of classes object, like okay, how many class we have. So the white test and all white range, which both are the same, because we have the same class for train and text. Shape of 1 means there's 60,000 for 0, and 1 or 10 for 1, and number of pixels. So the number of pixels are 28 into 28, means the 784. So now define our model. So how we can define our model? So we will use two hidden layers with 256 and 64 neurons. So first of all, in the hidden layer, we will use the ReLU activation function, and in the end, we will use the software activation function. ReLU activation function, as we just saw above before, that the ReLU is look like this. It will simply pass value if the value is positive, and for negative it will simply pass the zero value. Now what is software execution function? We know that if we want to use if we want to the binary classification problem, then we will use the segment because it will give the value of 0 and 1. But software activation functions gives the probability for all class. Okay, so here we have 10 classes, and for 10 classes the activation function gives the probability, and the if any classes have the highest probability, it will be our label. Okay, so this is the input of our software function, and it is passing to the layer software value, sorry, function, and we will get the probability matrix for our output. So our model is look like this. We have the input of 784, then we will have the first hidden layer of 784 into 256 dimension, because we have 256 neuron in the first hidden layer, then 64 neuron in the second hidden layer. So the combination of these weight matrix is 256 into 64, and in last we have the 10 classes. So the multiplication with these last previous neurons is 64 into 10. So it is something look like this, right? So define our model. So here define our baseline model. So model is equal to sequential, sequential, as we imported, and this is the sequential model. Then we will add layer in model, model dot add dense. So dense. Now first hidden layer we have the 256. Now what is my input dimension? Now input dimensions are, I already write number of pixels. Okay, so number of pixels 10. What we have, what is the activation function for this rel? So write activation rel. This is my first layer. Okay, now just copy it, paste for the second layer, because for second layer we have the 64 neurons. Now we don't need to define our, sorry, this is not, we don't need to define our number of input dimension here. Okay, so this is the second layer. Now simply copy and paste. This is my final layer where we have 10, but before number of classes we already used these num classes. So num classes is equal to 10, and activation function is software. Okay, sorry, and we will return our model. Okay, so model dot add tags. So this is our model looks like, with the 256 neuron in the first, 64 in the second, and 10 in the output layer. Now let's create the object of our model, baseline model. Okay, and model dot summary will give us the idea of the parameters, the num pixels. Okay, so num pixel, copy it, use. This is the same, I don't know why it's giving error. Okay, yes, so this is our model looks like. Now in the first layer we have this 256 neuron and 299,000 sorry, 200 and k something parameters. So how this is parameters can be calculated? So we have 784 input parameters multiplying with 256 neurons. Okay, so 207 plus, after also calculate the bias. So for individual neuron there is one bias. So for 256 neuron we have 256 bias. So this is for one layer parameter. Same as for second, like 256 into 64 plus 64. Okay, and same as for third. So total parameters are this, and you can say that the number of parameters for this small model. So that's why we required much more computation for this deep learning neural network task. And then now the compile model. So here we need to define the loss function and the optimizer. So the loss function here we will use the categorical cross entropy because we have categorical, and we will use this categorical cross entropy loss function. The formula is look like this, but we have directly available in the keras, and optimizer is equal to SGD, means stochastic gradient descent. It is the gradient descent algorithm with much improved version. So simply pass model dot. Okay, so before that we need a optimizer. Optimizer is stochastic gradient descent. Now here we need to define the learning rate. I am defining 0.0001. Okay, and then model dot optimizer, sorry, model dot compile. I am passing optimizer is equal to opt, and loss is equal to categorical cross entropy. So this is the loss and the optimizer. Now we have to train our model. So simply write model dot fit. Now what is my train? X train is my image. What is my label? So Y train is my label. And I have to pass. I have to pass the batch size. Batch size is equal to 32. And how many times? So iteration means the epochs. Here epochs is the iterations. Let's say 5 times. And finally the verbose means the learning process, how I want to see my learning process. So this is verbose one. Later I will show you the example of verbose too. And okay, we need one more thing. Here I want matrix is equal to accuracy. Okay, so again run this cell, and now model dot fit train labels batch size epochs and works. Okay, right. So just simply it will take some time to process. So this is my first epoch. So the loss and accuracy is very less, and it will take some time to train. Why this accuracy is very less? Because I took a very small learning rate over here. So let's try with the different learning rate, like 0.003. Now run this cell, and again run. Okay, still it is very less. Right. And you can also okay, I will try. I'm going with this accuracy right now. Later we will improve our model. So let's test our model. So how score is equal to model dot evaluate. Now I have the test data, so x test, y test, and here let's say I will try with the verbose and then with the one. So okay, so this is the loss is very high and accuracy is very low, and simply press this. So I am already calculated. So the error is very high right now. So this is my model is doing very poor on my training set, but we can change our optimizer here. Okay, so I am simply writing ADAM optimizer. It is the adaptive momentum optimizer, and I can again run this. Okay, so okay, I have to pass, and then okay, next time I'm going with verbose 2. So you can see that the pattern will be different. So this time the pattern is different. You can say the accuracy is really high because we changed the optimizer algorithm. So the optimizer algorithm simply works well for this particular model. So this is how you need to try and test and improve your model. And now I'm testing for my test data, and okay, so my accuracy is 94%, which is far better than the previous one, and error is 5%. Okay, so that's great. Now my model is working well on train data, again working well on test data. You can also change the epochs. Now how many times I want to iterate on my data set. So let's say I'm going to 10, and I'm changing my batch size. Let's say this time I'm going with 64. So just change, see the change in my accuracy. So already my accuracy is 94 in the first epoch. It will take some time. So there is a kind of open, you can also use the Google Colab. This Kaggle have the kernel, so they have already predefined libraries and available for us. So you can say that see that. So till now it is working on CPU. I can change it to GPU and TPU also. So this is where you can start with the programs. So the accuracy is 97%. Now again test is on my test code, and the error is less vary 3%. So now we can predict our any images with the help of this model. So I already write the code for this prediction. So I imported two images over here, image of 3 and 7. So what I'm simply doing, this is the images of 3. So it will CV2 will take help us to read the images. Then I am converting to the grayscale imaging. So it is has the 3 channel. So I am converting 3 into 1 channel, and then I am passing these images and again converting into the and reshape the images of 1, because we our model the input is 784 in input error. So here I can simply write prediction is equal to model dot predict classes of x, because this time my image is x, and then probabilities is equal to model dot predict probability x. And then if I simply enter, so okay, my model is predicting very good. So the predicted value is 3, and the probability across all numbers. So this is one hot encoding, right? So this is for 0, this is for 1, this is for 2, and this is for 3. So the model is predicting 3 probability, and that's why my output value is 3. So this is how we can predict the value. Okay, let's try with the seventh image. The seventh image, okay, and again run this shell. Okay, so predicted value is 7. So this is how we can use deep learning to help us for prediction and the classification task. And let's coming to the our slide again. Okay, so this is the same kernel which I just ran. You can simply download it from here and just use it on Google Colab to and practice it for your own self. And then I'm just writing these the two fun website. You can also check out this website first. So this is the graphical representation of the neural network. Let's say we have the input data just look like this. We have these two neuron in the four hidden neuron and two in the second layer, and this is the final output. So I am taking the learning rate of 0.003 activation function. You can select anyone. Let's say select the ReLU or 10. And the regularization means that it will help us to set your value very small. If the value will be very high, then activation will just vanishing the gradient. So that's why L1 and L2 regularization is the simple term adding in the gradient descent step. So it is the very helpful, but it will you can learn later in this regular because it is a very huge topic. So right now I'm just selecting L1 regularization, learning rate I'm not, and this is my classification. Now this is the epoch. You can simply run this button. So you can say that our test loss is decreasing and training loss is also decreasing, and the learning rate is very small, so it takes some time to go to the minimum point. But now if I am say that my learning rate is 0.001, then the same activation function and just pass. So it is fastly decreasing, right? The loss is fastly decreasing. So this is how you can just play around with the deep learning. And second website is also very helpful, like the Google has the teachable machine. You can simply create the simple model and predict your own faces very easily. It is also help. Okay, so the image project, you can say that. Okay, so let's take a look at the webcam. It will record, click some images. Okay, for a second it will simply just holding the pen. Okay, so now I am trained the neural network of the 50 epochs. Batch size, let's take a 64. Learning rate is 0.01, and export model train. So it is training right now. Okay, so my model is trained, right? So this is the two class simple classification. If this is the real time camera input, and if I am simply passing the pen, then it is the class 2 like pen, and class 1 is my face. So this is how you can export model for your website and all. So these are the two websites, and lastly I am providing you the starter guide that how you can start with the deep learning. It is also very great repository on GitHub, like books, courses, all are there. So you can simply just go through these courses and start learning about these the computer visions and deep learning and all. And you have some important papers to read. Then so it is really great repository for the starting. So that's all about from my side. Thank you for being here.
Wonderful presentation, Manthan.
Thank you, ma'am. Now the Q&A session. If anyone have any question, just simply drop in the comment section or just simply tell us.
You can put in chat box, or otherwise you can unmute your microphone and you can ask. No issue.
Okay.
Oh, Mona ma'am is saying very nicely explained, sir.
Thank you, ma'am. It's a kind pleasure for me to share what I know, and Animan gives a great opportunity to share and give service for.
Mona ma'am is faculty at GP.
Okay, thank you, ma'am. Thank you so much.
Yeah, please, anyone. Ankita ma'am, if you want to ask. Nidhi ma'am, if you want to ask.
Hello,
Ayush,
ma'am.
yeah.
Hello,
Please,
ma'am.
yeah, Ankita.
Yeah, I would like to say something. Ma'am, sir has done a really very good presentation and really a nice explanation. So we can
Thank you.
adding some more knowledge in our mind. So really, sir, really
Thank you, Ankita.
Thank you so much, ma'am.
She
Thank
is
you.
a faculty, but she too is
Pithawalla.
in our college.
Yeah,
Oh,
yeah, ma'am.
thank you so much, ma'am.
Yeah, any student want to ask anything?
Anyone have any questions?
Rashi, Rutvi, Prem, anyone? Dev, Keshav, anyone would like to ask anything?
I will share the deck with everyone, so you can just refer the repository. Okay.
Yes, anyone would like to ask anything?
No, ma'am.
Okay, no issue. So let me say thanks to Manthan Solanki.
Thank you so
Thank
much,
you,
ma'am,
Manthan,
for
for
giving this
amazing
opportunity.
presentation on deep learning using Python. See, today's world is of deep learning only, and everyone wants to work with deep learning. And the way you have explained is really very good.
Thank
And
you.
the way practically you have demonstrated the thing, that was also very good, isn't it? Now,
Thank
I
you.
request all of you to please open your webcam so I can have the photo together. Please open your webcam, all of you. અંકિતા મેમ પાછળથી તડકો બહુ આવે છે તમારો ફેસ નહીં દેખાતો
Yeah, just wait a minute.
યા
Actually, we are in so we don't.
યા please all of you, I request all of you to open your webcam so we can have the photo. Mona ma'am, Nidhi ma'am, Dev, Rashi, Prem, Keshav, Vivek. Please open your webcam so we can have the photo together. See, people are still thinking to open their webcam. No issue, I can take the
You
photo.
are ready to share the photo.
Yeah. Okay, no issue. So, lastly, if you want to
Thank you.
ask anything or otherwise we can leave. No? Fine.